So we started with the theory part, and now let us go over the practical part of correlation. I provided this Excel file, the Anscombe's Quartet dataset, on Blackboard for you to experiment with. Before starting our business case study, I would like to go over a concept very known, which is called the Anscombe Quartet puzzle, that made a lot of people wonder about some of the concepts related to correlation and related to visualization specifically. So we have here four data sets. So this is the first data set that it has some attributes, values of two variables or two attributes, the x and the y. So this is set number one. And we also have another data set number two, with two observations as well, the x and y, and the third one and the fourth one. What was observed in this unique data set that, as you can see, the numbers are different. However, if you try to discover the mean of x in every single data set of those, you will find it's the same. If you try to find the variance of x in every single data set, you will find exactly the same value. If you try to find the mean of the y's in those data sets, in each one of those four, you will find it the same. If you try to calculate the variance of y, also is the same. Okay, or closely between 4.12 to 4.13. If you calculate the correlation between x and y in each single set, they are very close to each other, about period 816 and period 817, very, very close. Um and if you try to create the regression equation for each one of those data sets, you come up with the same equation, y equals 3 plus 0.5 multiplied by x. If you try to look at the r squared for testing the fit of the model, also you come up with very similar number. So people will assume that those data sets are very similar. However, the only way to discover the differences between these data sets is by uh, visualizing the data. So, and that's a habit I would like from you always to try before even starting. Look at the histograms of your data, look at the scatter plot, try to sense your data and see what's going on. So, let me try to plot this data. So this is the first data set the yellow one. As you can see, this data almost there is a line that can fit this model, and the relationship is linear between those the axis and the y's. Let me plot the second data. Okay. As you can see, it's totally different distribution of the data. It's more, you can see there is a curve relationship here between the x and the y. Okay, let us try the third one. In this third data set, you can see almost that you have um, a complete line. Let me darken it. A complete line, and you have actually an outlier in this data. So those are not at all similar to each other. These data sets are no way you can consider them very closely related to each others. And let us look at the last one, just to take a look at it. Even that's the fourth set is more puzzling than all the rest, because here you can see, yes, you have an outlier far away in this data set, and on the other hand you can see a vertical relationship between the x and y, which means there is a one, almost a one value of x, and you can tell, look at the x, all of it 8 but 119, which is this one here. So it's one value of x in association with y. Okay, so this is the only way to see the differences between those elements is by looking at it visually. So it's very good habit always, whenever you are dealing with data and trying to model it, to look at the scatter plots or to look at the histograms of the data at the beginning. Okay, so let us start working with our data. So here you will find also your data chapter 04 dataset.csv, comma separate value type of data. Let us open it with Excel just to see the heating oil data set. So this is our data. Gonna insert a table here. Okay, make it lighter so we can see it. Let's look better. Okay, and this is our data set, and you might save it like Excel after you opened it with Excel. It's up to you. It's not gonna change anything with the data. I'm gonna save it as Excel extension. Okay, and let us now work with RapidMiner on this model, correlation model, create a model, and observe the correlation coefficients in the correlation matrix and find the relationships between the elements in this data. Also, you have your chapter available for you to read. So if you want to follow along either with me in the video or by following the steps that you have in your book chapter. As you can see, we open it as CSV, but it doesn't matter. And all we did, we brought the correlation matrix and then we observed the values. So let me do the same to be consistent with what you had in your book. Okay, I'm gonna start with not gonna upgrade. I started with a white blank page. As you saw in the tutorial of RapidMiner, you start with this process screen. This is where you drag your data and operator and you start building your project. So first of all, let me bring the data that I am working on. So I'm gonna bring the data. Let's see. Okay, so this is a CSV, so this is a data set. You bring the data, and as you can see, it noticed that the first row is a header row, so automatically it observed it. Notice also it's a comma separator. It helped us in this way. So this is one way to bring the data into RapidMiner. And during this process, actually, you can make some changes. If you click on this arrow here, you might change the type of the data. It says integer, you might keep it as it is. If it's wrong, you might change it. Also, you might change the role if sometimes maybe the role is you want it to be, this is an ID or label or weight. We're not gonna make those changes. I'm just trying to explain to you. You can rename the column and you can exclude some columns if you're not interested in them. So this is one way to bring, and I'm gonna keep it where I created this repository. This is one way to bring data into your repository. Okay. However, there's another way that shown in your book. So from here, you under the data access, under the read, you have the CSV access. You might drag the operator and start working with that. And in this case, I'm gonna select the output of the read CSV operator to the results. And after I do that, I click import configure wizard, and very similar to what you saw previously, I go and select, as if I'm repeating the process here. I'm showing you another way to bring the data. As you can see, we ended up in the same screen when I just imported the data. Are you happy with that? I'll say yes, finish, that's look good to me. And as you can see, automatically pick those predefined configuration for our file. So RapidMiner is smart enough to understand the data and to adjust it with some regular expressions that you really don't need to code it and to write it. Okay, now if it's good what you are done so far, you are good to go. Usually I like to save my process even if I'm not done. So if you right click on the repository you're in, just click store process here. You will be prompted with a dialog to enter the name of the process. I will name it correlation for heating unit. Maybe you can name it whatever you want, anything to remind you what kind of project was this. So as you can see now, the name I gave to this process, it became underneath the folder, and it has like a geared icon that shows you this is the process or the project, you know, if you want to consider it as a project in RapidMiner. So now I can run this. So always remember, whenever you do changes inside your process place, you have to run it so you see the result. So we ended up exactly the same image we saw when we brought the data automatically with the import data. So this is your data with all those attributes that came from Sarah's company. Okay, it tells you down you have about 1218 examples, which means rows, 1218 rows, with me, which means you have 1218 houses. And you have six regular attributes, which is the name of those six attributes we saw in this data. Insulation rating, one of them, outdoor the second, etc. You can look at the statistic, and this is what you should do. You look at the missing value, 0. We don't have any missing value, which is great. We see the minimum and the maximum. If you click on each one of those attributes, you should see the histogram, and you should see also the average and the standard deviation, which will help you somehow. If you click on the open visualization, you should see it in a big visualized view that helps you understand what's going on with that data. Okay, so really this is a very nice, good way. You don't have to go to the previous page. You can click from here and pick something else. Let's say I want to look at the number of occupant distribution. And now this is the second histogram. And as you can see, there is some skewness in this data. You know, most of the houses had occupants between 1 and 5, and those who reported between 6 to 10 really, or 9 actually here, 6 to 9 really were rarely represented in this data. Okay, if you're doing a statistical analysis, you might consider checking off those values and not considering them part of your model. Since we are doing data mining, and we will explain in upcoming classes why we are not dealing with those simple aspects over here, and we are keeping the data as it is, and you will have better understanding about why. Okay. What else? You can look at every one of those and examine them. So you can see all these for each one of them. It doesn't look like we have any problem with the data. Otherwise, if you had text entered by mistake, you will not see the type integer, will be text here. So it could be nominal. So as you can see here, everything looks to me, makes sense and good to go. Okay, as you can see in top of the RapidMiner window, the views, you have the design and the results. Those are the one we're gonna focus mainly on in these classes. I have some additional deployment Hadoop you might see in your version, Turbo, Prep, and Auto Model. And in this case, we're gonna concentrate on design and result. We're gonna see the rest in upcoming classes. Okay. Now, so let us bring the correlation. Just try to write correlation, and you should start seeing under modeling what is called correlation matrix. And if you don't see it, that's mean the version of RapidMiner you're working on is not complete. Otherwise, you should see it. So drag it and link it to this purple line. If you're not able to do that, so let me back up a little bit. If you're not, you can delete this line and put the new operator and then re-link those manually. And in this case, you have to link both outputs, the examples and the matrix in our case. Okay, so let us run this. And here we go. We can see that RapidMiner went ahead and generated the correlation matrix with coefficients that we discussed in the theory part. And as we mentioned before, that the color makes sense to you. It means the darker the color of the cell, the higher the correlation in both directions, either positive or negative. Okay. Beside that, you can see a pairwise table. If you click on the left side, this one gives you an order of the correlation, which is a nice way to look at it. So if you keep clicking on the correlation up and down, you should see it in this way. So you remember the theory, the blue chart where I showed you how the correlation strength goes from 0 to maximum 1 or from 0 to maximum -1. So imagine the 0 is located in this area here. This is a 0. So everything is going up. It means more higher correlation. Okay. So from here you can see the home age and heating oil use is the highest positive correlation, which is really good. And insulation rating also with the heating oil use, also positive correlation. On the other hand, on the negative side, you will see the insulation rating and the outdoor temperature is the highest in the negative direction, which means one of them goes up insulation, the outdoor temperature goes down. Okay, so if the insulation rating is high, that means, or the opposite, if the outdoor temperature is low, the insulation rating is going up, but they have high value or strongly correlated with each other. And don't forget the concepts we covered in the theory. If some of those are high but really doesn't make a logic sense to you, you ignore those. You don't consider them with your inside your conclusion of the business case. Also, you can look at what is called the matrix visualization, which is a little bit color coded in a better way. So you can see the high red is highly correlated, so you can visually see it quickly. The blue is also highly correlated to the negative direction. So you might focus on blue and the red to make your case to tell a story about this data. Okay. Let's see here what is so you can also save it. Actually, you can export this image if you like it to add it to a report. You can do this in your assignment to export the image as a PNG and add it to your report. On the other hand, what we can do, if I go to the data, okay, so as you can see, I have a couple of links. This is the one I opened at first, so you should see two links outside your in your results window. So if you go to the data again, you can do visualization on your own with the data. Okay, so from here you might decide to do some type of let's see what we have over here, and I show you some of this in your handout. Here's a scatter matrix. So this is more of this is, let's say we say the heating. Let me go back. We found out that the heating oil was really highly correlated with the home age, let's say. So you might apply this and look at what's going on with the data. You might add all of them. So let me add all of them. And that will create a complete, uh, a chart. Minimize the size a little bit so it fits the window. Okay, so this is can show you what we saw the correlation matrix, however, is based on each pixel, so you can better understand what's going on with your data. And the plot style, you might want solid. Uh, okay, let's see, as a dot will be a better, maybe minimizing the size, they are too big. So you can start tweaking this data to help you uh, better understand what's going on with your data. And you can change the type. Okay, cancel. So if you look at the same what we saw, so this is like you don't see anything if you trying to map the same attributes with itself, of course. So let's see the one we noticed, which is heating oil with the, so here's the heating oil with association with usage, and as you can see, heating oil usage was what let's say the home age, this one here. As you can see, a linear relationship between them, and we noticed we had a very strong relationship among those two. Okay, how about here? So in this one, the outdoor temperature, really we didn't consider that because we were convinced that logically it doesn't make any sense to us to look at it in this way. And of course there are many different ways to look at this data and to visualize it to better understand it. Okay, so that's it when it comes to RapidMiner, how easy it is to give us an understanding of what's going on in our data, with the correlation matrix with the values we found out, and accordingly we, as you notice in the theory part, we gave recommendation to Sarah what she should do next. Mainly our advice was to re-aggregate this data for new customers and make sure to aggregate based on the season, and not only to take one point of statistical data, but rather consider the season and consider maybe a monthly basis or weekly basis, so you will have a higher granularity level of the data to visualize it and to better understand her customers. Okay, so let us see what else we showed in the theory part. So I did here a scatter matrix between the heating. Okay, let's see. This is over here. Maybe I give you a little bit more to what I was able to represent in this data. So the scatter matrix, I picked the heating rating here. So let's see. Insulation, heating, all of them, okay. And then on the other one, okay, I color it by the heating oil used. So the more heating oil, it goes to the, so it made more sense in this way to represent the data, and to just to make it look more easier to interpret. So as you can see, the heating oil, the more usage of heating oil, which is represented in a darker red color, so the more heating oil being used, the accordingly it was associated with the home age. So the older the house, we found out, the more heating units were used at this house. Okay, it makes sense. Okay, so that's about how to use RapidMiner to interpret your results. So let me close RapidMiner, and remember always after you finish your analysis to save your process so you can reopen it in the future. Okay, so I'm closing this. How about R? So let us open R, and if you are and that, as I said, is optional, but it's good to know how to use R and to do some type of analysis with R. Okay, and so if you installed R and the R Studio, let us run R. So let's see here, R Studio. Okay, now I had it done. I had this. Okay, so okay, let's say import. This is CSV. Let's say it's import as a base. Didn't understand it for some reason. Okay, there we go. Here's our data. Yes, this is what we want. Automatically bring, yes, import the data. So here's the data. As we saw in the RapidMiner, we can see it in R, and R brought it to us, and we can view it also under the global variables. Now you should see this data, chapter 4 data. Okay, if I maximize this one a little bit. Okay, so here is the data. Here is the data we are using, so the same one over here. Okay, so what we said there, if we want to run the correlation, we can do the following. So when we write the data, actually in this, it put it in a variable called chapter 04 dataset instead of chapter 4 correlation data. It's okay. So let me start by naming an object chapter 4 correlation. You can name it whatever you want, and I am gonna call a function called correlation, and as you can see it pops up automatically when you call it, and I'm gonna use this data, just copy it, and which is called chapter 4 dataset, and the method I'm gonna use is the Pearson, so equal to, very easy, just the text, so you have to add Pearson, and that's it. It's closing the parentheses, and it should you should see it available in that way. Now if you want to look at it, either, so this is the one we just created, so either you can see it, double click it, or you can, here it is, this is the one here as a matrix. Either you click it and open it, or you can call it by using the view function. So what you have to do is here you're gonna just call view, and then from here you're gonna call chapter 4 course. So pay attention, it's case sensitive, so you have to be consistent with whatever you use. Whatever you use, lowercase or uppercase, is the same. So as you can see, it brought the same numbers we saw inside RapidMiner. Now we mentioned in the book that you can use another type of correlation that are more robust for outliers, and I ask you to Google that concept. It's easily in R to repeat the command line just by using the arrow on your keyboard without writing. So what I'm gonna do, I'm gonna repeat this correlation function, but this time I'm gonna use Kindle. Okay, so that will give you a different values. If you wanted to keep the old one, make sure to rename it with a different name, like you would name chapter 4 correlations 2 maybe, or kill. Okay, so those are totally different numbers than what we saw before. Try to investigate it online. What are the differences between these two? As I said, using RStudio is very easy and convenient. I will help you learn R with time. Okay, so all what we did here, I'm gonna repeat very quickly. First of all, I named a variable chapter 04 dataset, and this variable in which I called a CSV file by using the import method from R. So we have now the data set as a matrix exists in that object that is called chapter 04 dataset. Then what I did, I called a function called view, pay attention, capital V, view, and in between this, I just listed the name of this matrix so I can see it on my interface. We looked at it and we saw the data. After that, what I did, I called a function core, C-O-R, and what I put in this function, two parameters. The first one is the data that I want the R to implement or to execute the correlation function on it. And then I informed R that I wanted to use the Pearson algorithms as a method for applying the correlation. I repeated that by using the Kendall method, and I viewed the result. That's all we did here. Okay, so what else? As I said in this chapter at the end, that you have an exercise to do. Try to do it on your own with R. Is optional, but this is how you will get practice with R. It's mandatory to do it with RapidMiner, and you're gonna submit your report of this case in a Word document as listed on Blackboard. Good luck on that.